All right, so I think I'm recording. Let's take a look at this word problem. It's a mixture problem. I want to do it by two different methods, by the bucket method and by the seesaw method. How many milliliters of pure chocolate must be added to 150 milliliters of chocolate topping that is 50% chocolate to make a topping that is 75% chocolate? So let's do it by the bucket method, and I always draw these little containers that I visualize as buckets. It just helps me organize the problem. So I have these two ingredients that combine to get me a final mixture. Um, how many milliliters? So there's my variable, and we're going to let it be X of pure chocolate. So here's my pure chocolate, which if we're measuring the concentration of chocolate, we're calling that 100%. And I don't know how many milliliters I'm going to use right now. We have a 50% mix, so a 50% solution, and that we know that we have 150 milliliters of it. Our final concentration has to be between these two values, and it is 75%. And if we add X milliliters plus 150 milliliters, then we'll have X plus 150 milliliters as our volume. All right, so now we want to use this to set up an equation, and so we multiply the concentration times this volume, and we have 100x plus 50 times 150, and that will equal 75 times x plus 150. Now, in other word problems, when you have a percent, you typically move the decimal point over 2 places, but since that we're using a percent in every term, it doesn't matter for these word problems. But I debated whether to just go ahead and constantly move it over just as a good habit, because I know in many other problems that you'll do, you'll have to move that decimal point over, and sometimes students forget to do that. So if we take 50, if I turn on the calculator so it'll work, 50 times 150, 7,500, and 75x, and 75 times 150, 11,250. All right, so we want to get the x by itself. If I take away 75x from each side, I'll have 25x, and if I take away 7,500, I'll have 3,750. How do I do that? There we go. 3,750. Let's divide that by 25. 150. Yeah, and that makes sense, because if you just look at the numbers and think about the averages, you've got a pure here, you've got half here, you want the final mixture, the midpoint between 50 and 100 is 75. So I guess some people might have looked at it and just did it in their head without the equations and stuff. You want to show your work, though. You need to some algebraic support, or at least write down some type of thought process of how you saw the proportions being such that it was that the 75 was the midpoint, that was halfway between the 150, so the equal amounts here produced a mixture that was the midpoint. So let's do this by the seesaw method, and we should get the same answer. most of the time the numbers are such that you really can't, I can't do it in my head. It's not a type of a proportion that's quite so simple as this one. So if we do the same problem with the seesaw method, we identify what we call the weak concentration, the in between, and the strong. And what was weak here was the 50% chocolate. What was in between was the 75%, because for strong we had pure chocolate at 100%. That's what the variable was how many milliliters of pure chocolate. So our X was the volume of pure chocolate, and they told us that this was 150 milliliters. So we need the distance. The distance between 75 and 50 is 25, and the distance between 175 is 25. So we have 25 times 150 is equal to 25 times x, and if we divide both sides by 25, we get that x is 150, and that was milliliters that, of, over here I should have put of pure chocolate. I'm glad they spelled chocolate for me, because I always misspell it. All right, same answer, two different methods. I hope that helps, and I will talk to you later. Bye.